All right, so now we are about to talk about transistor as a regulator. Remember we said a transistor can be used as a switch, as an amplifier, and as a regulator. So now we have a circuit, this circuit that is called series voltage regulator. In this case, you can see that our load, RL, is in series with our transistor and our Zener diode. Remember, a Zener diode, this is the only diode that conducts when it is reverse biased. So if we take a loop in this direction, like that, if we take that loop in that direction, you see that we are saying in this case it will be minus VL minus VBE plus VZ is equal to 0. This is a closed loop. So if we add the voltage drops across these points, the load resistor, the transistor, and the Zener diode, we are saying minus VL minus VBE plus VZ is equal to 0. So if we rearrange this, setup in this loop, it must give us, if we make VBE as the substitute formula, if we take VBE to this side, it will be VZ minus VL is equal to VBE, which is the same as this equation. Are we together? So we are saying for us to regulate the output voltage, remember we want to regulate the output voltage, we want to get a certain value of voltage. We want to manage the output voltage to a certain level. That means our input voltage is unregulated. So we are saying, in this case, remember this voltage, the VZ, is the constant voltage. When you reverse bias a Zener diode, it will conduct and it will maintain a certain voltage under reverse bias conditions. So we are saying our VBE, if we increase VBE, what will happen to VL? What will happen to VBL? We are saying if we increase VBE, our VL also increases. If we decrease VL, that is the voltage across our load resistor, our VBE also will decrease. Why? Because the VZ is constant. So in this case, we are regulating the output voltage based on the input voltage. Remember VBE, this is the base emitter voltage that will cause the movement of charges from the emitter terminal into the base. So this is how we regulate the output voltage under series voltage regulator. All right, then we move on to another circuit which is called a shunt voltage regulator. Remember, shunt means parallel. So in this case, our load resistor, RL, is in parallel with our transistor and our Zener diode. Our load resistor is in parallel with our transistor and our Zener diode. So we are saying, remember, voltage in parallel is the same. So the voltage across our load, which is VL is equal to the voltage across our Zener diode, which is VZ plus VBE. All right, so we are saying the voltage across our load resistor is equal to the voltage in parallel, that is, in voltage across our Zener diode plus the voltage across our base emitter voltage. Are we together? So if we make VBE the substitute formula, that means if we take VZ to this side, it will be VL minus VZ, which is equal to be equal to VBE, which is the same as this equation. So how do we regulate the output voltage in this case? So remember we said these two are in parallel. And the voltage across our Zener diode is constant, is a constant voltage. So if there is an increase in VBE, that is the voltage across the base emitter junction, if there's an increase in VBE, that will result in an increase in in an increase in VL, are we together? So if there's an increase in VBE, it will result in an increase in IL, in VL, in the voltage drop across our load. Remember, when you increase VBE, the base emitter junction, we are also increasing the movement of charges from the emitter junction into the base. And those charges, they will result in the collector, in the collector terminal. And collector terminal is the IC current that will flow through our load. Are we together? So if we increase the movement of charges from the emitter to the base, that will result in movement of charges into the collector. And the collector current will increase the voltage drop across our load. So in this case, our VBE, the base emitter junction, is regulating the output voltage, which is the voltage across our load, which is VL in this case. So we are controlling the output voltage based on VBE, the increase or decrease in the base emitter voltage. So in this case, we are using our transistor as a regulator. We are regulating the output voltage. All right, then the last but not least circuit is constant current regulator. In this case, our assumption is the emitter current is approximately equal to the collector current. Remember, the emitter current, this is where our charges emanate from. And the collector current, this is where our charges are collected. So in this case, we have RE, which is a resistor connected to the emitter terminal. So we're saying the voltage drop across RE, if we look into this loop, we are saying, all right, we are saying minus VRE plus VZ minus VBE is equal to 0. And if we make VBE the subject of formula, if we take VBE to this side, that means VBE will be equal to VZ minus VRE, which is the same as that equation. Are we together? All right, how do we regulate the output current, which will regulate the output voltage? So in this case, remember we said VBE will result in more charges. If we increase VBE, we are increasing more charges from the emitter to the collector. So if IE, emitter current, is equal to IC, that means if we increase the voltage, the emitter current, it will result in more voltage drop across RE. In other words, if we increase the voltage drop across RE, this will result in decreasing VBE. Why? Because the Zener voltage is constant. So if we increase the voltage drop across RE, that means VZ minus VRE, that will reduce the VBE. Are we together? And the opposite is true. If we decrease VRE will result in VBE increasing. Are we together? So we're saying in this case, we're going to have the same, we're going to have constant current as our output current. Why? Because in this case, VBE is controlling the VRE voltage drop that will result in IC current being equal to IE.